Hi, in this video, we'll be discussing GMAT Official Guide 2017th edition Quant Problem Solving question number 122. Let's have a look at this question. Look at this question. The question says if n is a positive integer, that is n is greater than 0, and n values are integers, that is 1, 2, 3, keeps goes on like this. The product of all integers from 1 to n inclusive, both 1 and n inclusive, is divisible by 990. Alright, what is the least possible value of n? So product of all integers 1 to n, right? Say for an example, if n is equal to 3, what does this mean? 1 into 2 into 3, so which is equal to 6, which is nothing but here in this case, right? Here in this case, it's nothing but 3 factorial, right? Say for an example, if they have given n is equal to 4, 1 into 2 into 4, which is equal to 24, which is nothing but 4 factorial. So basically here n factorial, the question is whether n factorial is divisible by 990. If n factorial has to be divisible by 990, whatever the 990 in the denominator, whatever the factors it has, n should also have the same factors. That is, n factorial should also have the same factors. To figure out the factors, let's prime factorize 990. So what is prime factorization? Any number greater than 1, any integer greater than 1 can be expressed as product of primes. That's what we are going to do. We are going to write this as product of primes. It's nothing but 99 into 10, but 99 and 10 are not primes. Let's further break this down. So 10 can be written as 2 and 5, where 99 can be written as 9 and 11. 9 in turn can be written as 3 square, right? So 3 is a prime, 9 is not a prime, so we are writing 3 square into 9 into 11. 9 into 11 is 99, so right, so 9 into 11 99, 2 into 5 10. So we have break this down with only primes, 2, 3, 5, 11, all are primes. Now if n factorial has to be divisible by 990, n factorial should be containing all these factors. So basically, since 11 is the biggest prime here, so that means n has to be minimum 11 factorial, then only we will have 990. Otherwise we will not have 990 inside the n factorial. Say for an example, what I am trying to say for an example, if we have n has some 10 factorial. 10 factorial is nothing but 1 into 2 into keeps goes on till 10, right? So in nowhere you are going to find from 1 to 10, nowhere you are going to get the 11, right? To get the 11 you need to minimum put n value as 11, right? So 11 factorial is where the first 11 gets started. So in that case n has to be minimum 11, so answer has to be here D. You can eliminate all the other answer choices, right? Otherwise, if somebody looking for what would be the alternative way, as per the back solving rule, whenever we see a word called minimum, least, right, lowest, always will start with the least possible value. If you start with the least possible value here, if n we take it as 8, that is 8 factorial. 8 factorial maximum it's going to be 1 into 2 into maximum it will end with 8. It will not have 11. We need 11 inside it because 990 is having a 11. Maximum prime in the 990 is 11. So in that case you can eliminate A, likewise B, answer choice B, which is 9, likewise 10 also we can eliminate because 10 factorial will not have 11. Minimum what we need is 11. Maximum could be anything. Maximum also you can take 100 factorial, but the point is not about the maximum, the point is about the minimum. So answer has to be here D, 11. That's it. I hope this is clear. Thank you.